Hello Physics 30s and welcome to Lab 21, Measuring Planck's Constant. I'm going to explain how this circuit was set up based on the instructions that are given in the lab manual, and then I'll show you how we take the data collection for each of the LEDs. So the first step is to take a potentiometer. This potentiometer is kind of like a dimmer switch, but for current. That it has a knob that turns side to side. We are going to start with it all the way turned counterclockwise, all the way in the clockwise direction. So that's the maximum resistance setting. Then we're also going to use a battery. This battery is a Duracell battery, 6-volt Duracell battery. We take the negative terminal of the battery and connect it with an alligator clip all the way to the left-hand terminal of the potentiometer. And then the right-hand terminal of the battery, or the positive terminal of the battery, which I'm not going to connect yet with the alligator clip, is connected to the right-hand terminal of the potentiometer. Don't worry about the colors of the alligator clips, they don't matter. That's just whatever alligator clip I got. Then you're going to take an LED. So the LEDs all look clear and colorless, but as soon as there's voltage passing through them, or as soon as there's a current passing through them, then they'll start to glow with one of 4 colors. The LED is, the ends of the LED are curved or bent so that they're easier for the alligator clips to grab onto. On the left-hand side of this LED is the short arm of the LED, and that is connected by an alligator clip all the way around to this 330 ohm resistor. So one of the sides of the resistor is connected to the left, to the short arm of the LED. The other side of the resistor is connected to, as we follow this, the center terminal of the potentiometer. The long LED terminal, so if we go back to the LED, the long terminal of the LED is going to be connected by this alligator clip to the right-hand terminal of the potentiometer as well. So I just connected that alligator clip to the other alligator clip. It'll still complete the circuit. Then when we turn the potentiometer, when we turn it back in the counterclockwise direction, you'll notice that the LED, if this is working, the LED should, when we connect the battery first, that is the first step. When we connect the battery and then turn the potentiometer to the left, now you'll see that this LED glows red, and as we turn it, it will dim until it turns off. As we turn in the opposite direction, it'll glow brighter as we minimize the resistance. So that's how this experiment is set up. The purpose of this is to see the smallest amount of light that comes out of the LED. And after we connect the voltage source to it, so the voltage source is going to be represented by these 2 prongs on the multimeter, which is set to voltage. We are going to take the minimum amount of light out of the LED. We're going to approximate that as being 1 photon and see how much voltage is required by the circuit in order to produce the minimum amount of light. So I'm going to show you, I'm going to turn off the lights, collect the data, and then show you on the multimeter how much voltage that took. Okay, I've turned the lights off, and I know it looks like there's no light coming out of that LED, but there's a very, very tiny glimpse of light coming out of there. When I connect the prongs of the voltmeter across the LED, then we get a voltage of 1.70. So for the red LED, we get a voltage of 1.70 volts. The next LED we're going to test is yellow. I've already set it up. Now when I turn the potentiometer, you can see that it's going to glow yellow, and I will adjust the potentiometer so that the smallest amount of light comes out of it, then show you what the voltage will be. Okay, again, it looks like it's turned off, but this is the smallest amount of light that can come out of the yellow LED. When I attach the probes to it and measure the voltage, we get a voltage of 1.83 for the yellow LED. Okay, the next LED is set up. so that when I adjust the potentiometer, so you can see what color it is and how it will glow, you can see that it starts to glow green. So this is our green LED. And again, I will adjust it so the smallest amount of light possible is coming through it, and then we can measure the voltage. Okay, there's the smallest amount of green light coming through. Now when I place the probes to measure the voltage across the LED, we get a voltage of 2.63 volts for the green LED. All right, the last LED that we have to set up is set up across the alligator clips. When I turn the potentiometer so that some light comes through, you can see that this LED is the blue LED. So again, I'll adjust it so the smallest amount of light comes through and then measure the voltage. Okay, so we have the smallest amount of blue light coming through this LED. When I connect the probes across opposite sides of that LED, we can measure the voltage. As soon as I set this up, we can measure the voltage to be, it's jumping around a lot. Let's try this again. 3.00, let's try this again. 3.00 volts. Okay, those are all the data sets that we have for you for this experiment. You'll notice that in the data table, there's amber as an option. We don't have any amber LED, so you are just going to record the voltages for red, yellow, green, and blue. And then once you have the voltages, you're going to plot a graph of voltage as a function of frequency, and then use this graph to find the experimental value for Planck's constant. If you have any questions, let us know. Otherwise, good luck.